So this is our last trig lesson of the year, and we're going to be solving quadratic trigonometric equations, which just in its title sounds a little bit intimidating. If we keep in mind what we learned a few lessons ago, and then also just that we can write this with an x and think about how we would solve it that way, it's not too bad. So here I have 9 secant squared theta minus 16. I'm solving again for angles between 0 and 360. Okay, so I'm going to have to think about the ASTC. I'm going to think about this equation as if there was an x in for secant theta. So if I was solving 9x squared minus 16 equals 0, here we see a quadratic trig function because it's squared. This is the first time we've solved with these. I would factor this with the difference of perfect squares. So 3x plus 4, 3x minus 4 equals 0, and then I would solve and I would subtract 4 and divide by 3. So I would get negative 4/3 from that one. Here I would add 4 and divide by 3. This is working with the second factor, and I would get positive 4/3. So when we're solving the trig equation, we would factor it in the same way, except instead of 3x, we would get 3 secant theta, and then we would have plus 4 minus 4. So in the solving process, and I'll write out a little bit more for this one, just because it's new, I have 3 secant theta plus 4 equals 0, and 3 secant theta minus 4 equals 0. So what I said but didn't necessarily show over there, I'm subtracting 4 and dividing by 3. And you see we get the same answer as we got over here for x. On the other side, same thing, but I kind of want you to get to the point where you can do this in your head, so I'm not going to show this one the same way. I'm adding 4 and dividing by 3. So I end up with secant theta equals positive 4/3. So there's my two equations. Now I need to solve. I'm not done because my goal is to find theta, not secant theta. So I'm going to erase what I have over here on this side, and we'll write them over there and start to solve. So my first one says secant theta equals negative 4/3. So here, I can't ever use an inverse with secant because I don't have it on my calculator. So I have to use the fact that cosine is its reciprocal. So cosine theta equals negative 3/4, right? I just flipped my fraction, and now I can start to do my ASTC with this. So cosine is negative, right? So on ASTC, it's not positive, it's negative. So I'm expecting angles in the second and third quadrant. So next I do the cosine inverse of negative 3/4, and actually I want to do positive 3/4, right? Because I want to get the reference angle so I can put it in those quadrants more easily. So the cosine inverse of 3/4 is going to give me 41.4 degrees. Then putting that answer from here into quadrants 2 and 3, I have 180 minus 41.4 and 180 plus 41.4 to get into those two quadrants. So this is going to give me 138.6 degrees and 221.4 degrees. Now remember, that was just this equation that we brought over here. We still have to solve the second one. So right now I have 2 answers so far, right? And I need to get possibly 2 more. So the first thing I need to do is take the reciprocal of that secant value. So cosine theta equals 3/4. I'm going to do my ASTC. So I know this is a little messy. I'm going to box off this part. Okay, cosine is positive in this second equation, so I should have answers in quadrants 1 and 4. So from here, I'm going to do the cosine inverse of 3/4. I already know what that is because this was difference of perfect squares, right? So we had just positive and negative of the same answer. So in quadrant 1, that's 41.4 degrees. And in quadrant 4, sorry about that, that's going to be 360 minus 41.4, which is 318.6 degrees. So when you type this into Delta Math, I would have to use commas between my answers, right? And I have four different answers for this problem. So here's our second problem. We have 5 cosine theta minus 2 cosine theta. I should have written nearest tenth. I'll just write it on the side. I forgot to write rounding. So we have another quadratic trig equation. We always want to write this with x's first, just to see how we would solve it. So I have 5x squared instead of 5 cosine squared minus 2x. So here I see that this is just a GCF. I would take out the x. And I would get that x equals 0, right? So we'd set this factor equal to 0. And I would get x equals add 2, divide by 5, so 2/5. So we're expecting something similar over here. My GCF in this case is cosine theta. So when I factor that out, I get 5 cosine theta because I factored out one of these 2 cosine thetas. So just like x squared, that's cosine squared theta, and we write it a little bit differently. And then I took the cosine out over here, so I just have a minus 2 left. So from here, my 2 smaller equations, because I can split it up now that it's factored, are cosine theta equals 0 and 5 cosine theta minus 2 equals 0. So from here, I'm going to start to solve each of these. I do have enough room here, so I'm just going to draw a line down the middle. This one is kind of an interesting situation because I have cosine theta equals 0, so it's not really positive or negative here. I'm going to consider it as if it's positive, but I'm really expecting answers on the border between positive and negative. So I'm going to write it down as 1 and 4 as if it's positive, but I really am kind of expecting to get 90 and 270, right? Because that's in between the positive and negative quadrants. So we'll see if that's what happens. So when I do cosine inverse of 0, I do get 90 degrees. So as I said, not really in quadrant 1, but I'm going to write it down there. And then if I did 360 minus 90, I would get 270. So that type of thing happens when I'm on the borders between those quadrants, when either I have sine or cosine equals 1 or sine or cosine equals 0. Over here, I would add 2 and divide by 5. So for the second one, I would get cosine theta equals 2/5. So here, cosine is again positive. I'm just going to draw a line here to break that off. So if it's positive equals a positive number, I'm in 1 and 4 again, and that's fine. You can have multiple answers in the same quadrants. There's really no rules about your answers having to be in each of the quadrants or anything like that. So cosine inverse of 2/5 is going to give me 66.4 degrees. Putting that into quadrants 1 and 4, the 66.4 would go in 1. And then in the fourth quadrant, 360 minus 66.4 would equal 293.6 degrees. So here are my 4 different answers. So here it says if sine squared theta plus 9 sine theta plus 18 equals 0, find theta to the nearest tenth, where 0 are thetas between 0 and 360. So we will write down this equation down lower. I wrote the directions a little differently just because you might see it this way in Delta Math. So we'll write down a similar regular equation with x. So I have x squared plus 9x plus 18 equals 0. So I see that this one requires reverse FOIL, or figuring out what adds up to 9 and multiplies to 18 here. So I put my two parentheses down. We don't have to do any sort of arc method or anything like that because we just have a 1x squared here. So I can put the x's in the front, and those two numbers are positive 6 and positive 3. So if I solved each of these, I would get x equals negative 6 and x equals negative 3. So here, if I factor, it should always work the same. So I'm breaking up sine squared theta into sine theta and sine theta. And I have a plus 6 and plus 3. So when I solve each of these, I get that sine theta equals negative 6 and sine theta equals negative 3. So we'll start with the first one. If I talk about my ASTC, sine equals a negative number, so not positive, it's negative. So I'm expecting answers in the third and the fourth quadrant. So if I type in sine inverse of negative 6 to solve for that angle, something weird happens. I actually get an error on my calculator. So this isn't something that you did wrong. This is just the fact that sine, if we think about the unit circle or we think about a sine graph, the biggest sine gets, the y value is 1. So there are no spots, smallest it gets is negative 1. I guess that applies more here. There are no spots where sine can equal a negative 6. On your graph, right, the range of sine is from negative 1 to 1. So there is no answer here. Okay, so there is no answer over here. Thinking similarly, I could go through that ASTC step, but there's also an error over here. Okay, so basically there is no answer to this question. And this often happens with either sine or cosine when we're solving these equations, because you could see where it would happen often when I'm doing this type of factoring, that I would get something that's outside of that negative 1 to 1 range. Tangent's not an issue. If you think about the tangent graph, it goes from negative infinity to positive infinity for the range. So it's really just with sine and cosine that you kind of have to be careful and just looking for spots where you get an error. So on Delta Math, what you would have to do is you just press enter, and it'll ask you, is this what you want for your answer? And then you would say yes. So you just don't type anything in and enter if you get one of these with no answers. Sometimes the equations, I'm just trying to cover everything, maybe you'll have one of these factors as sine theta plus 1, and you will get answers from one of those two factors. That's possible too, and you would cross out the other one. So hopefully through this little unit, you've seen that sine and cosine, which initially when you were in 10th grade were just these things that you use to solve right triangles, can be used to solve any types of triangles. That you can do everything you do with them that you do with anything in normal algebra. You can graph them, you can solve with them, and there's a whole lot more we didn't look at that continues where trig really is a piece of algebra as well.